Hello guys, welcome back to ABC Trainings. Today we are going to see topic number 9 in Creo Parametric. So first of all, let's go to 3D first. Relations and parameters. So in relations and parameters, we are going to see local parameters. What is the meaning of parameters and relations? Parameters that are created in the current model, you can edit local parameters in the model. External parameters, parameters created outside the current model and used to control some aspects of the model. External parameters cannot be modified in the model. For example, you can add parameters in notebook mode to define certain part dimensions. When you open that part, these part dimensions are controlled from notebook mode and are read only in the part. Likewise, you can create parameters in the PDM system and apply them to the part. Then user-defined parameters. Additional information that you can attach to geometry. You can add user-defined parameters to an assembly, part, feature, or entity. For example, you can create a cost parameter for each part in the assembly. Then you can include the cost parameter in your bill of materials, that is BOM, to calculate the total cost of assembly. System parameters. Parameters defined by the system. For example, the mass properties parameter. These parameters are generally read-only. You can use them in relations, but you cannot control their value. Then there are annotation element parameters. Parameters defined for an annotation element. Restricted value parameters. Parameters whose values and other properties are defined by an external file. Relations. Relations are user-defined equations written between symbolic dimensions and parameters. Relations let you capture design intent by defining relationships within features or parts or among assembly components. You can create relations on different levels: assembly, part, feature, or section. Now, section relations. Relations created in Sketcher to control geometry of complex section. Unless a section dimension changes, section relations generally are regenerated during a part regeneration. Part relations. Relations added on a part level during a part regeneration. These relations get resolved before features are regenerated. Then feature relations. Relations added to a selected feature during a part regeneration. These relations are resolved after a part relations, but before the regeneration of the feature to which they apply. You use feature relations to change feature geometry only after part relations are applied and some features have been regenerated. Now, understanding relation theory. Relations, also known as parametric relations, are user-defined equations written between symbolic dimensions and parameters. Relations let you capture design intent by defining relationships within features or parts or among assembly components. You can use relations to control the modeling process in the following ways: to control the effects of modifications on models, to define values for dimension in parts and assemblies, to set constraints for design conditions, for example, by specifying the location of a hole in relation to the edge of the part. Understanding relation theory. To describe conditional relationships between different parts of a model or assembly, relations can be simple values, for example d1 is 4, that is integer, or complex conditional branching statements. You can also use units in relations, for example okay. Now another part of this session is family table theory. See, understanding family table theory. Family tables are collection of parts or assemblies or features that are essentially similar but deviate slightly in one or two aspects such as size or detail features. For example, wood screws come in various sizes but they all look alike and perform the same function. Thus, it is useful to think of them as a family of parts. Parts in family tables are also known as table-driven parts. The following figure shows a family of bolts. The generic is at top of the figure and its instances are underneath. The generic is the parent. Now see, these all look same but they are having different parameters. Using family tables, you can create and store large number of objects simply and compactly. It saves time and effort by standardizing the part regeneration. Generate variations of a part from the one part file without having to recreate and generate each one. Create slight variations in parts without having to use relations to change the model. Create a table of parts that can be saved to a print file and included in part catalogs. Then using features. Okay, so now we have seen this. Let's go to Creo. then you can have a better understanding of this. Okay guys, now we are in Creo. So for understanding relations and parameters, we will draw one helical sweep. That will be easy to understand. Then let's draw on this plane. So let's change its dimensions to 30. Let's draw one center line here. Okay, click on OK. Now let's sketch the profile. Let's draw a little circle and change its dimension to 20 and click on OK. Now see, we have drawn a helical sweep. Click on OK. Now let's hide this planes here. Yeah, let's annotate this now. Show annotations. All three are present there, so just select all of them and apply. See, it's visible now. 20, 30, and the length, oil length actually, that is 300 for this. See, okay. Now in this component interface, let's go to model intent. Click on this. Here you can see the relations and parameters. So first of all, we will see the parameters. Here you can have a proper view of it. Now for adding the parameters here, you can click on this plus. Now parameter 1 we will treat as coil dia. It's a real number. Just put the value, that is 20. Here you can also add units to this if you want to. Okay, now for coil length we have taken 300. Serial number. Let's designate all this. Here you can also add the pitch circle, distance between them actually. Or you can add number of turns. So let's put it as 10 turns. We have kept it 10. Just designate both of this. So see, now we have given some parameters. 3 parameters we have given in this. Just click on OK. Now model intent, go to parameters. Parameters are here. Here see, coil dia we have given, coil length we have given, coil turns, that is number of turns actually, those are 10, we have given it. Also you can add some parameters like you can say prepared, yes or no. We don't want real number, it's a yes or no. So yes, no. Here we can click as yes. You can give parameters like exported, imported, or like in-house or what, like that. So these are the parameters that if you click on OK. Okay, so control profile dia, then put enter, then click on this profile dia. We have changed the dimensions name, so that's why it's showing like this. Click on this profile dia equals to this coil length, that is d0. Click on this d0 divided by, then you can insert the parameter from here or from here, that is number of turns. See, coil turns we have described it. Click OK, insert selected, click on OK. So see, that is how actually I have added a relation, that is for controlling the profile dia equals to the coil length, that is 300, divided by number of turns, that are 10. So this is how actually relations and parameters are used in Creo. Now we will see about the family table. Okay, so now we are going to see the family table in Creo. Let's go to new part, click on OK. For understanding this, let's create one extrude sketch view. Let's draw one circle over here, and the dimension, let's give it 200. Click on OK. Now the extrude length is 200. Let's give it 100. Yeah, click on OK. Okay, now click the surface and say sketch view, then go to a circle. Let's create another circle. Yeah, this much is okay. Dimension, it's, let's say 100. Click on OK. Let's extrude the circle, make the extrusion 400. Click on OK. See, we have drawn this part. Let's, yeah, you can see that this we have drawn. Now let's go to annotations and show annotations. Apply. Now it's showing us, here it's showing us 100. Extrusion length is 400. It's not showing us the upper one, so wait. Show annotations. Okay, now yeah, now see, component interface. From here you can go to family table, or in tool section here also in model engine you can go to family table, so you can go from anyway. Let's click on this family table. Okay, so this is the family table. See this, what is saying, insert a new instance at the selected row. Now see, instance file name, let's say it to bolt. See, add or delete the table columns. Let's go here. You can see family items generally it's saying. Let's add what dimension. D4 we have given, D3 we have given. We added only these two dimensions just for understanding. Actually, understand the concept first, then you can try it by giving all dimensions. Click on OK. Now see, it has taken the given dimensions. Now it is showing us here the instant part that it's making. Okay, if you want to create a similar part like this just by changing its dimensions, what you can do, just go to this. See, D4 is 400 we have taken, let's make it 500, and D3 is 100, so let's make it 200. Okay, you can make the number of parts actually. First of all, let's select this one and click on preview. We have changed the dimensions. Let's click on preview. D4 and D3. Okay, so preview. See, 200. I have made the 100. So first of all, close this. See, that means actually, like whenever you make some changes or whenever you want to make the similar part, but just by changing its dimensions, we can use this family table. You understand the concept? This is how actually we can make a number of parts in the same family, like number of screws, number of bolts, just by changing small dimensions. Actually, this is only two dimensions I have given here, but you can give 7 to 8 dimensions. You can manipulate each and every one depending upon the type of screw or type of nut you are going to use, like M1, M2, M2, whatever bolt you are using. So like that, you can change the dimension and you can use the family table. Okay. Okay. So this is actually the concept of family table. I hope you understand it. Let's meet in the next session.